10:23. Happy birthday, Red. I got to remember to call Red today.
Oh, it's Red's birthday. Tell him I say happy birthday.
I will. Common Core Standards. So today we're going to be doing story problems with logarithms. Yeah, so I do too, honestly. But the nice thing about this is that if the story problems are very specific, then you know exactly what we're doing, right? It's not like wide open. It's like, ooh, where do I begin? These are very specific, okay? So example, a bacteria colony doubles every 3 hours, okay? Initially there's 1,000 bacteria. So here's an equation that we could use. Y equals some A. If it doubles, 2, right? And we're going to go T over, in this case, N. And N is a cycle of time. So this stuff's going to double every 3 hours. That's my cycle of time, right? So we're going to go to model this equation. After T hours, we're going to go, okay, we're going to have 1,000. Y equals 1,000 times 2 to the T over 3. Because it's triples every 3 hours. So far, so good?
Oh, wait a minute.
Okay, so my A is my initial.
Where's the 3 hours?
Right there.
No, but where does it say that?
Right there.
Oh, it's just not a number.
So it's all good.
Sorry about it.
No, it's all good. So then, so now think about this. In 15 hours, it's going to double 5 times.
Whoa.
Okay, I'll say it again. In 15 hours, it's going to double 5 times because it does it every 3 hours, right? And that's why the 3 there makes it easy, because every 3 hours it doubles. So if we just plug it in, we're going to go Y equals 1,000 times 2 to the 15 over 3. And then we just use our calculator to get the answer, okay? So I'm going to go 1,000 times 2 to the power of 5, right? You guys agree with that? Boom. About 32,000, okay? Thumbs up? That's bacteria. Now, C, when will the colony equal 10,000? So that's its ending amount, 100,000, thank you. So I'm going to go, okay, I'm going to go 100,000 equals my 1,000 times 2 to the T over 3, okay? So my 100,000 is my ending population. Thank you, Michaela. So now I have to solve for T. Now one of the things I do know is I'm eventually going to have to take a logarithm. I'm going to, because I've got the exponent here, and I've got to float the exponent down. So I will have to take a logarithm to solve this. Well, that's no problem. I can do that. So first of all, let's divide by 1,000, right? And I'm going to cancel 1, 2, 3 zeros. So I'm going to get 100 equals 2 to the T over 3, okay?
Wait a second.
Mm-hmm. Change it to log form. I'm okay, right? So I'm going to go, okay, let's rewrite this as log base 2 of 100 equals T over 3. Okay, I just changed it to log form, right? So I went from exponential form to log form. You with me? Went from exponential form to log form. So then, what I'm going to do here then is, I can use my calculator, log base 2 of 100, right? So, get my calculator, my fancy math button. Remember how we did this? Oh, I got the old calculator. The old calculator won't do it. So, math on math. Log base 2 of 100. No, hold on. I got to do it again. Math. Log base 2 of 100. So I get an answer about 6.64. So I get about a 6.64 equals T over 3. Multiply it by 3. Am I going too fast? Times that by 3, multiply it by 3, times it by 3, and I get an answer about 19.93, or about 20 years. T equals about 20 years, okay? Now to graph it.
20 hours.
Oh my, I am so glad you're here today. Golly. Thank you, Makaiwa. Somebody smart sitting in the audience. I appreciate you. All right. All right. So then, it was supposed to be a compliment from Makaiwa. It was not supposed to be roasting anybody. Okay, the graph is actually pretty easy. Okay. So to graph it is pretty easy. We know this. We know that it starts at 1,000. So if I go, I'm graphing. I'm graphing the actual problem because it says graph it. So graphing is not too hard. So I know that I eventually have to get up. So if I go, say 1,000, 2, 3, 4, 5,000, right? 6, 7, 8, so forth and so on. I know it starts at 1,000, right? And I know after 15 hours, so if I go 5, 10, 15, after 15 hours I'm at 32. That's, it's even off my graph. Darn it. I could change my scales even more. Could I change my scales even more? Bummer. I should have all right, let me go by 10,000s. 10,000, 20, there's 30,000. 40, 50, 60, 70, 80, 90, I'm almost to 100. So if I start at 1,000 after 15 years, 5, 10, 15 at 32, okay? And I've got one more way up here, right? At 20 years, I'm at way up here, okay? And I can just graph it in. Does that make sense? All I needed was a couple of points in the right shape. I'll say it again. All I needed was a couple of points in the right shape. And I know what the shape is, that shape, correct? Because we're going to do an exponential. So I got that point, that point. I can even have a point way up here and just thumbs up. I just need the right shape. All right, let's look at number 2, okay? Okay, so polonium-210 has a half-life of 140 days. That's pretty bad stuff. That's super radioactive, right? A scientist has 300 grams. So half-life, let's start off with y equals a times 1/2 to the t over n. Almost identical equation, right? The difference is the base, the rate. Instead of doubling, we're going by halves, right? So m of t, well, okay, they want to go m of t instead of y. It's the same thing. So we'll go m of t, that's the amount over time, is equal to 300 times 1/2 to the t over 140. And Makaiwa in terms of days, right? But if I say years, you'll correct me, right? Okay, makes sense? Does the equation make sense? Okay, now, find the mass remaining after 1 year. Now, 1 year is how many hours? Well, or how many days? That's t equals 365. So we'll go, okay, m of 365 equals 300 times a 1/2 to the 365 over 140. Okay, and I'm just going to use my calculator to get that. Okay, I'm just going to use my calculator. Clear. I'm just going to go, okay, 300 times 0.5 to the power of 365 divided by 140. And I get about 49. So I got about 49.2, yeah, 49.2 grams of polonium. Pretty easy, right? So see, Zoe, these problems aren't too bad because they're extremely specific to what we're talking about, right? Okay, now, how long will it for it to decay to 200? All right, so we'll do the same thing. We'll set it equal to 200 equals our 300 times our 1/2 t over 140, and we'll solve. I do know I'm going to need to take a log. So I'll go ahead and divide by 300. So I got 2/3 equals a 1/2 t to the 140, t over 140. All right, I'm going to change it to a logarithm, but it's going to be log base 1/2, which is okay because our calculator could do that, right? Let's go log base 1/2 of 2/3 equals our exponent. So we're going to change it to exponential form. I know, Brittany, you're saying these guys aren't doing much more than we are doing, right? I know, but just a little bit harder, right? So we're going to go log base 1/2 of 2/3 equals t over 140. Okay, and I'm just going to use my calculator. We're going to go again into my special button in my calculator, right? We're going to go math. Oh, I got the old calculator. They don't do it. So I got to go.
0.584. What? It's negative 0.584.
I don't know. Let's find out. I'll tell you real quick. 0.5 of 2 divided by 3. 0.585.
Why was mine negative?
I don't know.
Keep doing the acronym. Negative.
And then we'll multiply by 140. Okay, times that by 140. Times by 140. And I get an answer of about 81.9. And that's in terms of days. 81.9
What days?
days. Yeah, because it says days right there. Okay, now before you guys go, please write this
What
one.
does it say?
Days. Okay, before you guys go, write this one formula down.
Oh.
Okay, you need this formula. T of S equals, you need this formula. T0. Write this problem down. T of S equals T0 plus Tn e to the negative kt. Okay, write that down, okay? And then I'll show you guys flex tomorrow how it works, okay?
Where does it show that?
E, T of N, okay? And then send, hey, will you guys send, let Ms. Hoya know that I'm waiting for her, okay?
Okay.
Okay, now, how does this work? This is called a cooling formula.
Hey, doesn't Mr. Biggs have to know?
I do. I'm going to be there real quick. Okay, this is my initial temperature. That's my, so this is my room temperature. This is the temperature of the coffee or liquid. And that's time. And this number is the number we have to find, okay? So,
Let's go.
cup of coffee has a temperature of 200 degrees, okay? Right? Right? And then, and it's placed in a room of 70 degrees. After 10 minutes, the coffee is at least 150 degrees. Okay, that's my time, okay? So first I've got to find this value of K. All right, so I'm going to set up my temperature 200 equals my temperature in my room, which is 70, plus the temperature that comes out. So it's going to come out at 150 degrees. Oh, am I doing this right? No. 130. Oh, it's the difference in temperatures. Hold on. This is okay. That's 130, so it's the difference in temperature between room temperature and the coffee temperature. E to the negative K times 10, okay? So here's my, am I doing this right? 150. Oh, 150's got to go here. Sorry, bad notes. 150 goes here because 150 degrees after 10 minutes. Okay? And I'll probably have to do this one again tomorrow when I get everybody back, including me, okay? Okay, so the trick is you're going to solve for K, right? So it's 150 degrees, the coffee is, after 10 minutes. This number is the difference, that's my room temperature, and this is the difference between room, that temperature and that temperature, okay? I'm going to have to teach this again, but let's keep going with it, okay? 150, oh, let me subtract 70. Subtract 70. So I got 150, clear, 150 minus 70, I got 80 equals 130 e to the negative k times 10. Divide, I got about a 0.61538 equals e to the negative k times 10 ln So, yep, ln, you're totally right when you said log, but I'm going to do ln, right? Does that make sense? Equals negative 10k, and I'll divide this by 10, so I'll go ln of that answer divided by negative 10, and I get k to be, so k turns out to be a negative 0.0485. Okay, so the equation I want is going to be this. Where's my equation? There it is. T of S equals my 70, because that's my room temperature, plus my 130 e to the negative 0.0485 to the t power. Okay, let me circle that. Okay, there's my equation, okay? I'm going to go through this again tomorrow, I promise, okay? I'll do it one more time, okay?
This is stressing me out so much.
How long will it take to cool to 100 degrees?
Plug 100 degrees in, yeah, for 100. And the 15, you plug the 15 in, so we plug the 15 in to get this, right? Yeah. And then I got to go. So here's what you got to do, okay? And I can do it real quickly, but for the 15 minutes, plug the 15 in here and let our calculator do the work, right? I will do this again tomorrow, okay? I promise I will. Okay. So I'm going to go and put the 15, I'm going to go 70 plus 130, and I'm going to go e to the negative 0.0485 times 15, and I'm going to get, this one's going to be 132.8 degrees is the answer to that one. On C, set it equal to 100. Negative 0.0485 to the t. I'm going to subtract 70, so I'm going to get 30 equals 130 e to the negative 0.0485 t. I'll divide 30 divided by this. I got a 0.2307 equals e to the negative 0.0485 t. We'll natural log both sides to solve for it. So we'll go ln of 0.2307 equals negative 0.0485 t. So we'll divide, we'll go ln of that number divided by negative 0.0485, and I get an answer about 30. So the time is going to be about 30 minutes, okay? And then to graph it, I'm just going to take numbers I know, okay? So I'm going to go minutes, 5, 10, 15, 20. And then temperature goes all the way up to 200, right? 200, 100.
30 minutes?
Yeah, I got 30 in there too, don't I? 30.
Okay.
Yeah, I like that. Okay, and then I'll just do a dot to dot. Some numbers I know. I know that it's going to be at 30 minutes, right? The temperature was 100, right? At 15 minutes, the temperature was 132, is about there. It comes out of the microwave at 200. The graph looks something like that. I'll do that one again tomorrow, I promise, okay? Okay. Yeah. Okay. Okay, and now the homework.
There's no homework at the bottom.
I know, I forgot to put it on there. The homework is... Oh, you know what? I did forget to put the homework on there.
They're back.
How did I forget the homework? All right. Let's figure out what the homework's going to be. Let's make the homework easy,
Okay.
not hard. Is it still recording? It is. I can stop the recording. Yeah. All right. I